Hello all. Today we will discuss the problems of mainly the canonical form of hyperbolic equations. We can consider the first problem. Consider the equation uxx minus 2 sin x uxy minus cos square x uyy minus cos x uy equal to 0. First of all, we have to find a coordinate system s equal to s of xy and t is equal to t of xy that transforms the equation into its canonical form. We have to show that in this coordinate system equation has the form vst equal to 0 and find the general solution. So here we are transforming the coordinate system from xy to st such that s equal to s of xy, t equal to t of xy. In this transformed coordinate system, we have to show that the canonical form of this equation is reduces to vst equal to 0, which is very simple form. Okay, and then we have to find the general solution. Okay. So for that, first we consider the equation or name the equation as equation number 1. That is uxx minus 2 sin x into uxy minus cos square x into uyy minus cos x into uy equal to 0. Now, first of all, we have to check whether this belong to which type of equation. First, we are considering or we are in this lecture, we are considering the hyperbolic equation. So, this will be an hyperbolic equation. So, comparing with the standard equation, LU is equal to AUXX plus 2BUXY 2BUXY plus CUYY plus DUX plus EUY plus FU equal to G of XY, isn't it? So comparing with this equation number 1, therefore from equation number 1, here A is equal to what? A equal to 1, B equal to minus sin x and C equal to minus cos square x. Okay, so B square minus AC is the discriminant delta of L. So discriminant delta of L is equal to B square. So B is minus sin x. So this will be sin x square minus AC. A into minus sin x, that is cos square x. And we know the identity sin square x plus cos square x is equal to 1, which is always greater than 0. This implies equation number 1 is hyperbolic. So in the last lecture, we have proved one theorem saying that the canonical form, when we change the coordinate system into theta eta, the canonical form of the equation will be u theta eta plus L1 of W equal to some G of theta eta, like that. So now we need to reduce this equation, or sorry, W of theta eta. We need to reduce that the equation as VST. Here we are taking the new change of coordinates as s and t. S equal to s of xy and t is equal to t of x comma y. Okay. Uh, okay. So this s and t, first of all we have to find s and t. We will take this s and t from the equations, from the characteristic equations. So the characteristics in this case, in general case, the characteristic equations for hyperbolic equations are dy by dx is equal to b plus or minus root of b square minus ac by a. So here the characteristic equations are given by dy by dx is equal to b. What is b? B is minus sin x. Minus sin x plus or minus root of b square minus ac, it is 1 by a. A is also 1, that is equal to minus sin x plus or minus 1. Now solving this equation, we will get two plus or minus 1 is there. So there are actually two characteristic equations and two families of characteristic equation. And solving this, we will get it to the values, two functions which we choose as S and T. So this is a separable equation. Both are separable ODE. So we can separate the variables as minus sin x plus or minus 1 into dx. Integrating on both sides, we will get y is equal to minus sin x's integral of we know derivative of cos is minus sin. So integral of minus sin is cos x plus or minus integral 1 dx, that is x, plus a constant, or we can write it as cos x plus or minus x minus y is equal to a constant. So we will take s as cos x plus x minus y and t as cos x minus y. Okay. So this is our S and T, which are functions of x and y. So now we are changing the coordinates into S and T, and we know how the equation will be transformed. Um, for that we have to calculate ux. In this equation we have to replace uxx, uxy, uyy, and uy. Okay, for that we have to find the consider the chain rule. So here we are taking the function let v of s comma t is equal to u of xy. Okay, or that is uh, u of xy is equal to v of s of xy comma t of xy. Now applying the chain rule, we can write ux as vs into sx plus vt into tx. Now we know what is s and t. S is cos x plus x minus y. T is cos x minus y. So here sx is minus sin x plus 1. Tx is minus sin x minus 1. Sy is minus 1. Ty is also minus 1 is equal to ty. Now Sx, substituting the values of Sx and Tx, we have Vs into minus sin x plus 1 plus Vt into minus sin x minus 1. Okay, now Uy is as in the same way Vs into Sy plus Vt into Ty, and we know Sy and Ty are equal to minus 1. So this is minus Vs minus Vt. Now we have to find Uxx. Uxx is what? Vs into Sx with respect to x plus Vt into Tx with respect to x. So here we have to apply the product rule of differentiation. Now in order to find the derivative of Vs with respect to x, again we have to apply the chain rule. That is Vs into Vss into Sx plus Vst into Tx into Sx plus Vs into Sxx. Now Sxx is minus cos x. Sxx is minus cos x, and okay. Okay. Plus Vt into Tx with derivative of Vt into Tx with respect to x. And expanding the bracket, we get Vss into Sx square plus Vst into Sx into Tx plus Vs into Sxx plus Vt into Tx with respect to x derivative. Now we have to find the derivative of the second term also. And we will give the values Sx square, Sx into Tx and Sxx. Okay, so substituting that values, we get Vss into what? Sx square. Sx is minus sin x plus 1 the whole square plus Vst. Vst into what? Vst into Sx into Tx. We know Sx is minus sin x plus 1. Tx is minus sin x minus 1. So it is of the form a plus b into a minus b. So the product will be a square minus b square. So sin square x minus 1. Okay. Then Vst term of over. Then Vs into Sx is there. Vs into Sxx. Mm, Vs into Sxx will be Vs into Sx is minus cos x. Okay. Vs into minus cos x plus. Now in this way we have to find Vt into Tx, derivative of Vt into Tx with respect to x. So Vt, when we find the derivative of Vt with respect to x, it will be Vts S6 plus Vtt Tx into Tx plus Vt into Txx. Again expanding this, the first three terms are similar. Then plus expanding this one term will be Vts into Sx into Tx plus Vtt into Tx square plus Vt into Txx. Again the first three terms plus again Sx into Tx. Sx into Tx is same, sin square x minus 1. So Vts into sin square x minus 1 plus Vtt into Tx square. What is Tx? Tx is minus sin x minus 1. Square means the minus sign will be got plus 1. So sin x plus 1 square plus Vt into Txx. Vt into Txx. What will be Txx? Tx is minus sin x into this one. So minus t minus cos x, same as Sxx. So Vt into minus cos x. Now combining all this, we will get Vss. Coefficient of Vss is what? Vss. Okay, minus sin x whole square, minus sin x plus 1 whole square. There is no other term containing Vss. Now Vst, there is Vst term and Vts term is there. Okay, Vts same term is there. Vts and Vst are same. Okay, so sin square and its coefficient is sin square x minus 1. So Vst into sin square x 2 into sin square x minus 1 plus Vst into 2 into sin square x minus 1. Then next Vtt term. Vtt term is what? Vtt term is only one term. So it is Vtt plus Vtt into sin x plus 1 the whole square minus. Now Vs into minus cos x is there and Vt into the remaining term is Vt into minus cos x. So minus cos x into Vs plus Vt, isn't it? Vs plus Vt. So this is our Uxy. Uxy. Let the equation be as we give the numbers. The equation taken as number 1, and here we can give uh, there is no other numbers given. Okay, so uy we needed now. Okay, uy, sorry, not this one. Put it as equation number 2. Then we needed uxx. So we were calculating not uxy, it is uxx. So uxx is equation number 3. This one. Now we have to find what uxy. Uxy and uyy. Uxy is same as uyx, which is equal to uy is in most simple form. So uy is minus w, minus vs minus vt with respect to x. We have to find the derivative with respect to x. So again uxy is equal to minus of vs. Find the derivative of vs with respect to x. So vss into sx plus vst into tx. Okay, minus vt with respect to x. Vts into sx plus vtt into tx. That is minus of vss into sin x. Sx is minus sin x plus 1. Then plus vst into tx. So what is tx? Tx is minus sin x minus 1. Now minus, again taking all the minus in the outside. So vst and vts are same. So this will be plus sx. Sx is what? Minus sin x plus 1. Vst into this plus, now the remaining term is vtt into tx. What is tx? Minus sin x minus 1. Okay, this is equal to minus of vss into minus sin x plus 1 minus 2 sin x into vst minus sin x plus 1 into vtt. This is equation number 4. Uxy. Okay. Now uyy we have to find. Uyy is minus minus vs minus vt with respect to y. So this is minus of vss into sy plus Vst into Ty plus Vts into Sy plus Vtt into Ty. So this is equal to minus of Vss into Sy. Sy is what? Minus 1 into minus 1. Now next term is Vst Ty Vts. Vst same as Vts. So 2 times Vst or Vts into Ty plus Ty will be there. Ty plus Sy will be there. Ty plus Sy is Ty and Sy are minus 1. So minus 2 Vst will be there. Minus 2 Vst plus Vtt into Ty, that is minus 1. Or taking all the minus outside, we get Vss plus 2 Vst plus Vtt. This is Uyy, equation number 5, I think. So this, let's put this as equation number 5. Now substitute 2, 3, 4 and 5 in equation number 1. We will get the transformed equation or the required canonical form. So it is equation number 1 implies what? Uxx is Uxx is VSS into, first of all we write the equation VSS into we have to write instead of Uxx we have to write its equation number 3. Uxx is given by 3 now. Equation number 3 is. So from equation number 3 it is minus sin x plus 1 the whole square plus Vst into 2 sin square x minus 1 plus Vtt into sin x plus 1 the whole square minus Ws plus Wt into cos x. Now this is the first term. Now the second term is 2 sin x into uxy. 2 sin x into uxy. What is uxy? Uxy we will obtain from equation number 4. Equation number 4 uxy is, yes, uxy is minus minus it will become plus. So 2 sin x into Vss into minus sin x plus 1 minus 2 sin x into Vst to sin x into Vst minus Vtt into sin x plus 1. This is minus 2 sin x into uxy. Now minus cos square x into uyy is that. What is uyy? Uyy is Vss plus 2 Vst plus Vtt. Then the last term is minus cos x into uy. What is uy? Uy is minus Vs So minus into minus will become plus. So cos x into cos x into uy. Uy is vs plus vt. Right side is equal to 0. Now we have to simplify these terms. Add the terms together with same terms. We have to show that this equation reduces to the form vst equal to 0. So all the higher order derivatives, higher order terms vtt, second order terms vtt and vss are all the coefficients of these terms, and vt, vs, all these terms are have coefficient 0 that we have to make. Now first consider vs cos x into Vs plus Vt, that is Vs into cos x, Vt into cos x is there. Is there its negative term? Yes. This is not W, this is V actually. So there is minus Vs plus Vt into cos x plus Vs plus Vt into cos x. So that terms will get cancelled. Now we have to, first of all, we have to concentrate on VST, not VST, VSS term. So if we take the VSS term, here VSS coefficient is minus sin x plus 1 whole square. Now again there is minus 4 sin square x, sorry, minus 2 sin square x is there. Then minus cos square x. So we can rewrite this VSS coefficients is uh, minus sin x plus 1 whole square, that is sin square x minus 2 sin x plus 1 will be there. Then in the first term ux term, then it will be 2 sin x into minus sin x plus 1, that is minus 2 sin square x plus 2 sin x, minus 2 sin square x plus 2 sin x. Again, sorry, again we SS term, that is minus cos square x minus cos square x. Okay. So, okay, this is the coefficient of VSS. Now we may consider VTT term. VTT coefficient. What is VTT? VTT here sin x plus 1 whole square. That is again sin square x plus 2 sin x plus 1. Then VTT term 2 sin x into, okay, minus 2 sin x into sin x plus 1, minus 2 sin x into sin x plus 1 means minus 2 sin square x plus minus 2 sin x minus 2 sin x. Okay, VTT term. Now VTT term is minus cos square x minus cos square x. Okay, plus VST term, coefficient of VST. In UXX the coefficient is 2 into sin square x minus 1. That is 2 sin square x minus 2. Then so the coefficients are VSS into sin square x minus 2 sin x plus 1 minus 2 sin square x plus 2 sin x minus cos square x plus VTT. Similarly we have sin square x plus 2 sin x plus 1 minus 2 sin square x minus 2 sin x minus cos square x plus VST into 2 sin square x minus 2 minus 4 sin square x minus 2 cos square x equal to 0. Now simplifying this, we have sin square x minus sin square x. This we can get cancelled. 2 minus 2 sin x and plus 2 sin x is there. Now sin square minus 2 sin square will be minus sin square. Minus sin square minus cos square will be minus of sin square plus cos square. That is, it is equal to minus 1. Then minus 1 plus 1 is there. So VSST into 0 will be there. Now VTT similarly in the same way, because this is plus 2 sin x minus 2 sin x get cancelled. Sin square x minus 2 sin square x, it will be minus sin square minus cos square is minus 1. 1 plus minus 1 is 0. Now VST, we have to concentrate on the coefficient of VST. VST here 2 sin square x is there, minus 4 sin square x. So minus 2 sin square x will come and minus 2 cos square x will come. Then minus 2 is there. Okay, is equal to 0 we will get. That is VST into, now taking that minus 2 outside, we will get sin square x plus cos square x plus 1 equal to 0. That is sin square x plus cos square is 1. 1 plus 1 that is 2. 2 into minus 2 that is minus 4. So we will obtain minus 4 into VST equal to 0. Since minus 4 is a number, we will obtain it as VST is equal to 0. This is the required canonical form of equation 1. Okay. Now we have to solve we have to solve from this. So VST is equal to 0. We know V is a function of S and T. So in order to get V, first of all we have to differentiate or integrate with respect to T. Okay, so integrating with respect to T, we will get this as a function of integrating with respect to T, we are integrating. So Vs maybe is equal to some function of arbitrary function of S, since it is a function in two variables S and T. Okay. Now again integrating with respect to S, VST, we will get it as VST is equal to integral f of S ds plus some integrating constant that we can treat as a function of T. Now we can read this, rename this as some function of S. Okay, or capital F of S. So V of ST is equal to capital F of S plus G of T. So this is the solution in ST coordinate system. Now, but our equation is in XY. So the solution of equation 1 is given by U of XY is equal to F of S. What is S? S was cos x plus x minus y plus G of T. What is T? T is cos x minus y. So this is the required solution. That is the solution of equation number 1. Okay, there is one more problem. Example 2.7. of the textbook. Consider the trichomy equation uxx plus x into uyy equal to 0 with x less than 0. Here we have to find a mapping q equal to q of xy, r equal to r of xy that transform the equation into canonical form and present the equation in this coordinate system. So this is the problem. First of all, you have to check whether the equation is hyperbolic, parabolic, or elliptic. Um, and then find the rest, and we know how the transformed or canonical form will be for each of these equations, these type of equations. Okay, then try to write the new function, that is v of qr. New coordinate system is qr, v of qr as u of xy. Then rewrite uxx and uyy in terms of v. Then you will get the canonical form. So try to do this problem as an homework. Okay, let's stop here. Thank you. Thank you all.